Good day everyone, this is Sir Hill Winslow Jr. from SDOQC New Era High School. Welcome to another Math Kwentuhan with Sir G. Another grade 10 lesson to be discussed. Without further ado, join me. In today's lesson, we're going to discuss quartiles for group data. So, if you could recall, we've just discussed the quartiles for ungroup data on measure of positions. So in today's lesson, we're going to deal with quartiles for group data. Alright, so let's dig in. So quartiles again are score points which divide the distribution into 4 equal parts. So 25% fall below the first quartile or Q sub 1. 50% are below the second quartile or Q sub 2, and the scoring 75% is less than the third quartile or Q sub 3. So that's how to interpret the result in quartile. So 25% fall or above, 50% below or above, and 75% below. Alright, so the formulas for quartile 1, 2, and 3 on group data are as follows. No? So Q sub 1 is equal to the true lower limit. I'll explain later how are we going to get the true lower limit. Then plus a quantity of the sample size all over 4 minus the cumulative frequency all over the frequency where the lower limit is located, and of course I for the interval. Alright, so for quartile 2, so that is equal to again the true lower limit plus twice of n, this time because your k is 2. Alright, then over 4 minus the cumulative frequency all over the frequency where the lower limit is located, multiply to the class interval. And for quartile 3, that is equal to the lower limit plus a quantity of thrice the sample size divided by 4 minus the cumulative frequency all over the frequency where the lower limit is located, then multiply to the class interval. So let me discuss the general formula for the quartiles. Alright, so Q sub k is equal to the lower limit plus a quantity of k times the sample size all over 4 minus the cumulative frequency all over the frequency where the lower limit is located, multiplied to the interval. Again, Q is for quartile, K is from 1 to 3, L is the true lower limit, of course N is the sample size, F is the cumulative frequency. I've discussed how to get that cumulative frequency. Small letter F, the frequency where the lower limit is located, so I'll discuss it later, and I for the scores interval or the interval. Alright, so supposing we are asked to find quartile 1, 2, and 3 of the frequency distribution of the scores of 50 students in geometry class, and we are asked to divide them into 4 equal subgroups. Alright, here are the scores. If you could notice, the score interval is 5, so therefore our I is 5 because 15 to 19 has 5 distance from 15 to 19 as up to 45 and 49. So that's how to get your I or the class interval, and these are the frequency of scores. So meaning from 45 to 49 there are 2 students who got that. 40 to 44 there are 6 students. 35 to 39 there are 11 students who got that scores. 30 to 34 10 students. 25 to 29, there are 12 students. 20 to 24, there are 5. And 15 to 19, there are 4. So these are the frequency of scores. And of course, your n is the number of samples. So we simply add the frequency in total of 50. So later, we're going to deal with the cumulative frequency. Alright, but before I answer that question, so let me, as I promised, so let's discuss the true lower limit. Alright? Alright. So, to get the true lower limit, guys, we need to follow these simple 4 steps. So take note that capital letter F is your cumulative frequency. Alright. I'll discuss it to you when we go back to the table. So the cumulative frequency should not exceed the value of kn over 4. So you have to take note of that. The cumulative frequency should not exceed. Then the frequency f, small letter f, is one step higher than the cumulative frequency. Alright? Then for number 3, we have to take the lower limit of the score where f is located. Then we are going to subtract 0.5 to the lower limit to get the true lower limit. Alright, so let's put these rules into action. So let's proceed. Alright, so again, going back here, guys, again, these are the scores, the frequency of scores. Alright, so again, the class interval is 5, alright, 15, 16, 17, 18, 19. So that's why we have 5 class interval. Alright, how did we arrive at 4? No? That is the question. So actually, we simply copy the frequency from 15 to 19. Okay, that's why we have 4 there. Then look to the left. Then get the sum between 4 and 5. So we arrive at 9. Then we do that until we reach the top. So 9 plus 12, that is 21. Then 21 plus 10, that is 31. 31 plus 11, that is 42. Plus 6, 48. Plus 2, 50. Again, at first, we simply copy the first frequency of the scores. So, kung ano man yung smallest score natin, yun yung kukopyahin natin. Then, automatic look to the left. Then, get the sum. So, 4 plus 5, 9. Plus 12, 21. Plus 10, 31. Plus 11, 42. Plus 6, 48. Plus 2, 50. So that's the end. So the number of sample, which is 50, and the cumulative frequency at the top must be equal always, no? Alright, and since we're looking for quartile 1, alright, so our formula is equal to the true lower limit plus a quantity of the sample size over 4 minus the cumulative frequency divided by the frequency of the score where the lower limit is located, and of course we multiply them all via the class interval, which is equal to 5. Alright, and getting the value of n over 4. Alright, since the sample size is equal to 50, so we simply plug in 50 to n, so that's why we arrive at 50 over 4, and we've got 12.5. And this is now the basis for us to get the cumulative frequency. So if you could remember the rule, the kn over 4 should not be greater than the cumulative frequency. So since this is 12.5 C4, so pwede ba 9, pwede ba 21, hindi, no? So the cumulative frequency should not exceed the Kn over 4. So that's why we choose 9. And from there, we look upward at 12. This is now our frequency where the lower limit is located. And we are going to take 25, that is the lower limit, and subtract 0.5 to get the true lower limit. So 25 minus 0.5, that is equal to 24.5, and we're going to plug in that in our formula. Then plus, of course, the quantity of n over 4, which is 12.5, so we just plug in, and your cumulative frequency, which is 9 here, all over the frequency where the lower limit is located, which is 12. Alright, and the class interval 5. Then we simply bring down 24.5, then plus, of course, simplifying the numerator, 12.5 minus 9, that is 3.5, all over 12 times the class interval 5. Then by using our calculator, 3.5 over 12 times 5 is equal to 1.46. Then getting the sum, 24.5 plus 1.46, and we gave it gives us 25.96. So therefore, quartile number 1 can be found at the 26th position. Okay, since we're going to round off, alright, is on the 26th position. Remember that the measure of location is, we are looking for the position. Alright, okay, so let's proceed. So let's get quartile number 2. Again, for recall, the cumulative frequency came from the smallest score from the frequency of score. So we simply copy 4, then look on the left side, so we add. Alright, the operation is addition. So 4 plus 5, 9, 9 plus 12, 21, plus 10, 31, plus 11, 42, plus 6, 48, and plus 250. So it should be automatic. Alright, so you practice, and you may find getting the cumulative frequency quite easy. This is simple addition. Alright, now our formula for quartile 2, our K now is 2, that's why we have 2 here, so twice n, because this is Kn, right? So twice n over 4 minus the cumulative frequency all over the frequency where the lower limit locates, and our class interval, which is 5. Then getting the value of twice n over 4, so since n is equal to 50, plugging in that value to the formula, we have twice of 50, that is 100 over 4, so we got 25. And again, take note, the cumulative frequency should not exceed this value. Alright? So therefore, we choose 21 as our cumulative frequency because 31 exceeds 25. Alright? Now, after getting the cumulative frequency, we look on the left, one step on the left, and that's where we can find the frequency where the lower limits locate, which is 30. And of course, we don't just need a lower limit, we need the true lower limit. So we're going to get that by subtracting the lower limit 30 by 0.5, then we will arrive at 29.5. Then we're going to plug in that to our formula. So therefore, quartile 2 is equal to 29.5 plus a quantity of Of course, your twice n over 4 is equal to 25, and your cumulative frequency is 21. Alright, and the frequency where the lower limit is located is 10, that's why we have 10 here. And of course, the class interval is 5. Then let's simplify. So bring down 29.5, then 25 minus 21 is equal to 4 over 10, then times 5. Okay, then simplifying. 4 over 10 is 2 over 5, then 5 is cancelled, so what is left is 2. Then 29.5 plus 2 is 31.5, or simply, quartile number 2 is at the 30 second position. Okay. Alright. And finally, we're going to get quartile 3. Alright, again, for recall, we get the cumulative frequency by simply copying the first element on the frequency of score. So we simply copy that, then look one step higher on the left, then get the sum. Alright, so 4 plus 5, that is equal to 9, and you do until you reach the top. Alright, and of course our formula now is your k is equal to 3, since we are looking for quartile 3. Again, your L here is the true lower limit, and this time we have thrice the sample size all over 4 minus the cumulative frequency all over the frequency where the lower limit is located, multiplied with the class interval 5. Now, getting the value of thrice n over 4, so plugging in the value of sample size, which is 50, so that is 150 over 4, and that is equal to 37.5. Again, take note, the cumulative frequency should not exceed the value of kn over 4, that's why we choose 31 as our cumulative frequency. Then one step higher to the left, then we will get the frequency where the lower limit is located, and that is 35, to be subtracted by 0.5 to get the true lower limit, which is 34.5, and we're going to plug in that to our formula. So quartile 3 is equal to 34.5 plus a quantity of, again, let's plug in all the values. Your 3n over 4 is 37.5, and your cumulative frequency is 31 all over the frequency where the lower limit is located 11, and your class interval 5. Now simplifying, again bringing down 34.5, then 37.5 minus 31 is 6.5 over 11 times 5. Then simplifying this in your calculator, so we will arrive at 2.95, then plus 34.5, so we will arrive at 37.5. Therefore, our quartile 3 is located at the 37th position. Alright. Okay, now so let's divide the distribution into 4 subgroups. Alright, quartile 3 is at the 37th position, quartile 2 is at the 32nd, and quartile 3 at the 26th position. Of course, the rest are 15 to 25. And what does it mean? So 15 to 25 is the lowest score, and group A has the score which are the highest. Alright, so 37 and 49. Alright, so that's how to use quartile for group data in dividing group into 4 subgroups. Okay, I hope that is clear. If there are some confusion, you may always pause the video, rewind, rewatch, and try to use your pen and paper at home to master the skill. Alright, so at this juncture, it's your turn, guys. So So, here is your problem. Below is the frequency distribution of ages of 50 faculty members. So let's find quartile 1, 2, and 3. Alright, so I'll give you 20 minutes to finish this. So please pause the video for 20 minutes before playing it again. Alright, see ya. Okay, your 20 minutes is gone. So let's check your answer. So, for quartile 1, okay, and that is located at 30th position. For quartile 2, it is located at the 35th position. And for quartile 3, it is located at 39th position. Okay, so therefore quartile 1 is on the 30th, quartile 2 is on the 35th position, and quartile 3 is on the 39th. So I hope you got all these answers correctly. If not, again, don't feel bad. So you may always pause the video, rewind, rewatch, and redo as many as you can with your pen and paper and scratch paper. Alright? So, have a good week. Until our next Math Kwentuhan, this is Sir Hill Consuelo Jr. saying, see you next time.